Adding and subtracting rational expressions. Example 5. 3x over x minus 4, subtract 2 over x plus 4. In this example, notice we do not have a common denominator. Each of the denominators are different. Even though the numbers and variables are the same on the denominators, the signs are different and therefore make the fraction different. As we look and compare and get ready to make our denominator, our first step of the problem is to look at our denominators and get them in factored form. X minus 4 is in factored form. It's factored out, and x minus 4 then has to be one of our factors in our denominator. As we look at the second fraction, x plus 4 is in factored form and must be one of the factors in our denominator. The next step is to see and to match up the matching parts and the missing parts of our factors to see what's missing and what needs to be multiplied. As we look here, we can see that the x minus 4 matches up the x minus 4, but the x plus 4 is missing. So we need to multiply by x plus 4 as the missing factor. That will give us 3x times the missing part, which is x plus 4. Now looking at the second fraction and comparing what's there and what's missing, the x plus 4 matches the x plus 4, but the x minus 4 is the part that's missing. So we'll multiply the x minus 4 on the bottom, and we'll multiply the x minus 4 on the top, because it's the missing part. Watching our signs very carefully here, that subtract sign has to come over, and then we'll take subtract 2 and multiply it by the missing part, which is the x minus 4. Now, be very careful here. It's very tempting to say we just multiply by the factor on the other side, and that is what works here, but that doesn't necessarily work in every case. And you'll see if you'll look at some of the other examples of problems where this doesn't work. In this case, I'm going to go on and finish this one. 3x times x gives me 3x squared. 3x times 4 gives me 12x. Negative 2 times x gives me minus 2x. Negative 2 times negative 4 gives me a positive 8. Adding like terms again, I'll get 3x squared plus 10x plus 8. Now, in this case, we could check to see if this factors. In this case, it actually does factor. There are factors that will work here. I will not go into the explanation of how this factors. If you would like to see that, you can either come by or see another example of how that factors. It will factor into 3x and x on the outside, and then it will factor into 2 and 4 as the last of the terms, and then a plus and a plus. Notice, however, it does not factor out any on the bottom, so we could either write 3x plus 4 and x plus 2 over the denominator, or the 3x squared plus 10x plus 8. Either one would be a correct answer. And since I've already started and took the time to factor it, I will write it that way. And again, if you need some help with the factoring part, be sure to stop by and see a tutor to help review on your factoring skills as well. Generally speaking, we will not hit the hardest of these factoring problems in these rational functions, although you may see some of these in these problems. So be aware of them and remember to review and keep in mind all that factoring that you've done in the previous classes and in previous chapters. And as I finish writing them out, remember either answer is correct. You don't need one or the other. And again, if you've watched the previous examples in this set, you'll notice that I do work my problems vertically. Your teacher may work them horizontally. Either way is okay. And the answer then is either 3x plus 4 times x plus 2 over x minus 4 times x plus 4, or 3x squared plus 10x plus 8 over x minus 4, x plus 4.